talking about machine learning. So I haven't uploaded in a long time, I know, and I have changed topic because I've been working on this topic recently and I thought about uploading it. Why not? So today we'll be talking about machine learning. So first of all, what is machine learning? Well, the word machine learning was coined by Arthur Samuel, and he said that machine learning is the science and art of making a robot or a machine learn based on huge amounts of data. That's the actual definition of machine learning, but without being explicitly programmed. A good example of this is a spam email bot. A spam email bot has to go through all of the emails and then say this is a spam, this is a ham. A ham is a non-spam email. This is a spam, this is a ham, this is a spam, this is a ham. So it has to train a model based on data. What will that data be? Thousands or even millions of different types of emails, spams or hams. We feed it into our model, and the robot searches for appearances in between the hams and the spams, and it modifies itself so it can give us the best accuracy score. And once it's done doing that, we've got a nicely trained model, and then we test it. We give it some data which do not have spam or hams. Like we don't tell if it's a spam or ham, and then it has to predict that. And then we actually go on and compare the predicted values and the actual values, so we have an accuracy score. This is called supervised learning. Machine learning can be used for a lot of things. If you were to explicitly program this spam email yourself, you have to study the problem, find some appearances that are related to each other in a spam or a ham, and then once you've done that, you have to test your model, analyze the errors again, go on, iterate until it's ready to launch. And once you launch it, some spammers may realize, oh yeah, that he's spamming every email with a for you inside, or this inside, with this word, with this image. Okay, so then they will change that, and you have to upload, and you have to download your code again, check it, test it again, find another model, find another code, and then upload it over and over again. And this process might go on for 1,000 years. But when you have a machine learning model, this can be done a lot easier. How? Well, because a machine learning model can be trained on the fly. Like you give it some model, you give it some data, and it learns. And when something changes in a spam email, it will change its model again, so it will meet those things. So machine learning can be with or without human supervision, or it could be batch learning or online learning or learning on the fly. Okay, so let's talk about with or without human supervision. With this type of machine learning can be divided into 4 parts: supervised, unsupervised, and semi-supervised and reinforcement learning. Let's talk about supervised. Well, supervised is where you give thousands or millions of data with labels. Let's say we want to train our model to guess the difference between a cat and a dog image. So we feed it millions of images of different cats and dogs. But we also give it the name of every image. For example, if this image is a cat, we write cat under it, so the robot will know that this is a cat. And this, we write dog under it, so it will know it's a dog. We do this with all the images. And one thing to do when you want to test your model is to give only 80% of these images as training models with their labels, okay, like it's a dog or a cat. We give it our model 80% of those images, okay? Let's say if we have 1,000 cats and dog images, we give 800 of them to our model. The rest 200 will be used for testing. How? Well, we delete the labels. Once it trains with that 80%, we give these 20% without labels for testing. And it has to guess the labels based on the model and the appearances it has found in those images. And once it's done that, we have to compare the predicted values with the actual values, giving us an accuracy score from 0 to 1. There are many different ways to do this, and testing, like having that value from 0 to 1, there are many different math algorithms and things like that to do that. But I will not dive deep into them. Some algorithms for supervised learning can be KNN, k-nearest neighbors. It can be SVM, linear regression, logistic regression. They can be decision tree, and they can also be random forests, and so on. There are so many of them. You just have to study them, and based on your problem, you have to choose one of them. There's also unsupervised learning, which is the exact opposite of supervised. This time, we don't give our model labels, okay? So we don't give our machine labels, so it won't guess the labels as well. It has to go through those images, 1,000 images, and search for appearances in their data, in their images. And once it's done that, it classifies them, it clusters them into different groups. Like, it doesn't know that these 100 images are cats, but it does realize that there are some relationships between these images, like the eyes, or the ears, or the fur. And it clusters them into one group. And the rest of the images, it might realize, oh yeah, they look like each other. They have this type of relationship, this type of relationship. It doesn't know it's a dog. It doesn't know they're dogs. But it just knows that they're the same. And it classifies them into another group. This is called clustering. And in clustering, we don't want values. We don't want predicted values. We want to check our clusters and see if it's accurately have clustered them. Sorry. So one way to check our accuracy score is to see if there are no dogs in the cats clustering, or there are no cats in the dogs clustering. Things like that. It's like easy to think about them. There's also semi-supervised. Another, an example to understand this better, semi-supervised, is Google Photos. You give it, you take selfies every day, and one of them, it once asks you, who's this image? Or who's this image? You say, it's me, man. It's definitely me. And the next day it asks you another image. It's me. Okay, so it realizes some patterns in those me pictures. You give it some labels. Some of the images, like 2 or 3 have labels. And then after that, when you upload images of yourself to Google Photos, it will realize that based on the appearances and the relationship between this image and the main me image, I know that this is a me. So I put it in the me category. Or this is his sister, I put it in the sister category, and things like that. So once you're done with that, after on semi-supervised, we have reinforcement learning. Reinforcement learning is based on a penalty and award system. You give it a penalty, like you have a robot that wants to learn the difference between a fire and water, okay? So it chooses the fire. When it chooses the fire, you know it's bad for the robot. So you get 50 points from it. You decrease 20 points from it, and things like that. And it realizes, oh yeah, I lost points. What does that mean? Oh yeah, that this is bad for me. I should avoid it next time. And when it goes to the water, you say, no problem. Yeah, and you give it 20 points, because it chose the perfect one. And thus, it has realized that when I get points, this is a good thing, so there's no problem getting close to water. Yeah, because I'm waterproof. Okay, so that's the exact thing of a supervision learning, and we also have batch learning. Batch learning, which is not based on human supervision, just something like that. It's not based on human supervision. It's just learning on the fly. So in batch learning, you feed your model lots of data, and then the model modifies itself based on that data. And once it's done modifying, you upload your code after validating and testing its accuracy score. And once you upload it, batch learning is not a really good answer or a really good option for fluctuating environments. Why? Well, because batch learning cannot get new data. You cannot upload new data as they come. You have to download the batch learning model. You have to feed the old data and the new data all again, and then upload the model again. which can be really frustrating and can use a lot of CPU, a lot of RAM, a lot of internet, a lot of money. And that is not a good option for fluctuating environments. If you have a website or a blog that can, I don't know, that doesn't change as much based on its data, the data that is coming, it doesn't change as much, like once or twice a month. That's like the most. And if it's like that, bench learning is a good option. But if it's fluctuating environment, it changes every day. New peers, new people come in every day. I don't know. It's not a really good option. One good option is online learning. Online learning is actually, you have to be offline to use it. But anyways, online learning actually learns on the fly. Once you upload your old data, it learns that the appearances, the relationship between that data, but it also deletes the data after it has learned its appearances, because it doesn't need them anymore. It has modified its model based on real-life data. And then you upload it, and when new data comes in, the new data goes in, gets checked, the model is modified, and then it's deleted again. That is a way better thing to do. So that's all I wanted to talk about today. If you have any questions, do drop them down in the comments below. I will be happy to answer them. Goodbye.